Number 14, the level of production of a company is given by 31 times x to the power 2 over 3 times y to the power 1 over 3, x units of labor. And y is the units of the capital. Okay, and then the company is currently utilizing, so the current level, currently, so utilizing 27 units of labor, or x equals 27, and the capital like 64 units. The problem asks if the labor is increased by 3 units per day. For the term, labor is increasing 3 units per week, per weeks. What does it mean? Labor is the x increasing plus sign. So this one means the dx dt equals positive sign 3. Okay. And then what else that we know? What will, the question asks, what will be the change? So the ask for what will be the change in unit of capital per week to maintain the current level of production. Okay, so this is a question. And when we look at the question, if we pull it out and write it as the symbolic form, will be the change in unit of capital per week. Per week, the capital is the y, per week, the per time t, and to maintain the current level of production. So the question asks for dy by dt. Okay. The current level of production, the current when x 27, y is 64, or the 27 units of labor, 64 units of capital. The overall picture for the Cobb-Douglas formula is the production level equals 31 times x to the 2/3 times y to 1 over 3. First of all, we're gonna find p at the current level of production. That's step number 1, okay? And then step 2, we're gonna find the rate of change with respect to time, to all terms, okay? For the first step, for the current level of production when x is 27, so P equals 31 times 27 to the power 2 over 3 times the y, which is the units of capital, or 64 to the power 1 over 4. Compute this number, we should get the 27 to the power 2/3. So this is the cube root of 27 to the power 2. And this one is the third root of 64. So we have 31 multiplied by 3 to the second, that's 9, multiplied by 4. Okay, then our P is 31. Let me check the number real quick. 31 times 9 times 4, which is 1116. So your Cobb-Douglas formula now is 1116 equals 31 times x to the power 2/3 times y to the 1 over 3. Okay, that's this is the implicit function that we have. Step number 1, we get the implicit equation. The next one, we're gonna find the rate of change with respect to time of the implicit function. So we're gonna have, let me change the color. So we're going to find the d by dt of 1116 equals 31 x to the power 2 thirds y to the power 1 over 3. So we're going to do term by term, left and right. The left side, so I'm going to rewrite it as d by dt 1116 equals 31 as a coefficient, d by dt of x to the power 2 over 3 times y to the power 1 over 3. Okay? We have one term on the left, one term on the right, but the term on the right side is in the product form. So this is a product. We're going to apply the product rule, same as before. The f times g prime plus f prime times g. So with this way, we just work on the normal way or apply the basic derivative formula that you've been doing. So the left hand side, the derivative of the constant gonna be 0 and then equals 31 as the coefficient, okay, or the constant multiple. The derivative, you see, this is the x and this is the x and y. So you're gonna use the chain rule or the general power rule as the process when you use the product rule. Okay, the first term, which is x to the power 2 over 3, multiplied by the derivative with respect to time of y to the power 1 over 3, and then plus the derivative with respect to time of the first term multiplied by the second term or y to the power 3. All right, so I just use the template of the product rule. And then the next step, I'm going to just apply the general power rule to each term. So let me see if I can clean up somehow. Yeah, eraser doesn't work. Yep, doesn't work. All right, I'm going to move on to the next slide, okay? So what we have is 0 equals 31, and then in the first term, the x to the power 2 over 3. I just copy it just in case. Make sure we have everything we need. And d by dt of x to the power 2 over 3 times the y to the power 1 third. And I'm going to check real quick to make it everything correctly. Power 2 thirds for the x and power 1 third for the y. Okay. And then to get the problem cleaner, you can divide all by 31 to get it out of the way, because 0 divided by any non-zero number, you're going to get 0. Okay, so we just work on the core piece of the problem. So now we have x to the power 2 over 3 multiplied by, this time we apply the general power rule. So the power becomes a coefficient, and then y to the power 1 over 3 minus 1, and then multiply by the derivative of the y with respect to t. So this step, we use the general power rule. And then plus, same thing, the power 2 over 3 multiplied by x to the power 2 over 3 minus 1 multiplied by the derivative of x with respect to time. Okay, I'm going to group these together, and then I will write the notes for that step as the use of the general power rule. So this one is from general power rule, and this one is the same way, general power rule, general power rule. And where this step is from using the product rule. Okay, now I have terms as the x, the y, the dx dt, the y dy by dt. I'm going to clean up the power or write it in a simplified form. And then the number, the 1 over 3, we treat it as a coefficient. So 1 over 3, x to the power 2 over 3, y to the power negative 2 over 3, multiplied by dy by dt. The second term, I have 2 over 3 multiplied by x to the power, now become negative 1 over 3. And I'm going to bring y next to it, just for the nice order, and then multiply by dx dt. Like a times b the same as b times a, what I mentioned earlier. Now, at this step, I have x, y, dx, dt divided by dt. And the y for the first term has a negative power. The second term has a positive, the x has a negative power. What, what we're gonna do, if you recall, the question asks you to find dy by dt at the current level of production. Okay, so I'm gonna put the note here as our goal is to find dy by dt at the current production level, which is x equals 27, y equals 64, and given the x dt to be negative, let me check the number. The x dt is positive 3. Okay, so this given information and the unknown that we have to find. So we have the x value, y value, we have the x dt value. But to manage the problem in the nice and clean way, I have 1 over 3, 2 over 3. I'm going to multiply all by 3 just to make the problem cleaner. Okay, multiply all by 3. So then my expression now becomes 0 equals x to the power 2 over 3. And at the same time, my negative power I write as a positive power. Multiply by dy by dt. Similar to the second group, since I multiply all by 3, all terms, so the coefficient of the second term becomes 2. And then I treat the negative power as the reciprocal of the positive power. And then multiply by dx dt. And then my goal is to find dy by dt. So I solve for dy by dt. Okay. If you do not want to rearrange the term, you can replace the number at this step and then rearrange the number instead of rearranging the expression in x. Okay. Excuse me. So recall it, we know the x value, y value, and the x dt value. I'm going to replace the value of that, of those numbers. So means 0 equals the x is 27 to the power 2 over 3 divided by y, which is 64 to the power 2 over 3, and then multiply by dy by dt, which what we are going to find. Okay, dy by dt. And then plus 2 times the y. What is the y? Y is 64 to the power 1 over 3. And the x is 27 to the power 1 over 3. After I wrote in this form, you can see that both for each expression, they share the same power. On my side notes, just for my convenience, for the x over y, both of them to the power 2/3. So that means I can write as x over y raised to the same power. Okay. And our case, the x is 27, the y is 64. You raise to the 2/3 power. What do I get? I take the cube root first, which I will get 3 over 4 and raise to the second power. So I will get 9 over 16 for the first group here. Okay. And then the other one, the 64 over 27, and both of them share the same power. So 64 over 27 to the power 1 over 3. That is the cube root of 64, which is 4, divided by the cube root of 27, which is 3. So this expression will give me 4 over 3. Okay. Now, I have the cleaner version, not in the x expression, as the 0 equals 9 over 16 times dy by dt plus 2 times 4 over 3. And the x dt is given to be the value 3. Okay, this one equals 3. I can simplify a little bit more. 3 and 3 reduce. So I have 0 equals 9 over 16 divided by dt plus 8. Recall, my goal is to find dy by dt. So I'm going to solve for dy by dt. Subtract 8 both sides. And then solve for dy by dt by multiplying both sides with the value 16 over 9. So I get, let me compute the number real quick. 16 multiplied by 8, that is 128. And then divided by 9 as the answer that we are looking for. Or it means this is the change in units of capital per week. Okay. As you increase the units of labor, so the units of capital will be decreasing. Kind of, they are going in opposite way.